Everyone, good evening. I welcome you all to the C++ session organized by Engineers Gurukul. So now for the topic for today, the topic which we need to cover today is related to very important concept in C++ or in making projects, and that is called as, any ideas to anybody? And that topic name is files and streams. So this topic is very important in our day-to-day life. Reason being, whatever we do in our project or whatever software we develop deals with saving data somewhere in hard disk or the storage, right? So if I need to make a software, if I had to code something, obviously I need to have some data in the program or the input output to be done via program. Only then I can assume that yes, my software is a very good software, right? Now, to understand the importance of this topic, okay, I'll give you one real life example. Okay, so let's suppose I'm having one you can assume like, okay, so this is your, let's suppose this is your RAM, okay, and I'm having one program here, okay, and there is one, let's assume there is one hard disk, right? So for hard disk, I'll be taking one like this, right? So what is this? This is my hard disk. This box, orange color box, is actually my program. Okay, the program which we write. Now, let's suppose in this program, I am taking a variable a whose value is 3. Okay, I'm taking a variable a whose value is 3. So you know that a program is always executed in your primary memory, that is your RAM, right? So as soon as this program is executed, this a variable will be having memory in the primary form, or I can say it will be stored, the memory of this value 3 will be stored in primary memory for temporary basis. Why I call it as temporary basis? Because until and unless this program is executed, a is equals to 3 will remain in memory, right? But as soon as my program gets terminated or it's completed its execution, your 3 will no more be there in your primary memory, or I can say it cannot be accessed later on after few days. Why it cannot be accessed after a few days? Because a is equals to 3 was assigned memory in the form of RAM, and RAM is a volatile memory which removes after a particular amount of time, right? Now let's assume this program is of bank. You are making a software which is called as bank management system, right? Now this program is of bank account, right? So from user, what we are taking is, we are taking here input, or I can say credit amount, which is equals to, let's suppose, 10,000. Okay, so this program is actually a program which take inputs from the user to store some data or to credit the bank account with some amount, and that is the amount the user credits is called as 10,000. Okay, now what happened? This program is starts its execution. User enter the amount, credit 10,000, and the program terminates. Now this value credit is equals to 10,000. It is not stored anywhere in the database, or it is not stored anywhere in the secondary memory. The next day, when the user goes to the bank and to debit this amount, yes, so the clerk over there says that your bank amount is zero. Account amount is zero. Why? Because this 10,000 statement, this instruction was nowhere saved in the database. So nobody has a proof that whether this 10,000 was credited or no. Since this value 10,000 was nowhere saved in the database, or it was nowhere saved in the hard disk, secondary memory. So the bank manager will say that your bank account is having balance zero and you cannot debit your account. So is it this program of any use if we are not able to store the data once we have inserted it and later on we cannot fetch that data? Is it of any use? I think it's of no use. See, if I am entering some data into this program, giving input on first day, that is, let's suppose I enter it on 22nd July, right? Now, after some days, let's suppose I open this program back again on 24th July, and I want to fetch the value of A. So I say I want to get the output of value A. Will I be able to get it? No, because this value A was nowhere saved in the database. So this is not a very good concept. So there comes the importance of files and streams. So what is actually files and streams? Whatever data we store, we give input in the form of program, that is saved in the hard disk in the form of files. Okay, that is saved in the hard disk in the form of files. So later on, if I open my project on 24th of July and I want the input, I execute the same program, I want the output of value of A, I can just directly go to the hard disk, bring this file back into the RAM and get data from here. So this is the importance of files in our program. So any doubt to anybody in this? Why we use files? Any doubt to anybody? Okay. Okay, this is the importance of files in our daily life. Now, let me just move this. So this is my program, RAM. Okay. Now, this is actually, let me create here a file. I'm having a file here. Okay, so this is my file. Okay, in which the data has to be stored. That is, the value of A has to be stored. I'll let you know. That is what I'm telling Abhishek, what is stream here. Okay, so the data has to be stored in file. Now, if I say the program takes the value of A is equals to 3 and I want to store this A is equals to 3 in the file, right? So the very first task by the user is to open the file and then store the data, isn't it? Can I store the data in a file without opening a file? Yes or no? Can I store the data in the file without opening it? No. So my first task is to open the file, right? Now, when I say open the file, by that I mean, what will happen? The same copy, see, normally the file is in hard disk, that is your secondary memory. When I say open the file, the copy of this file will be open in RAM. The copy of the file will be opened in RAM, right? The copy of the file will be opened in RAM, right? Or I can say this file will be brought into the RAM. Now, the next task by the compiler is to create a stream. I repeat, create a stream. So what do you mean by creating a stream? Create a stream means, just a second, let me just increase its width. So relieve it. So this is my creating a stream. Now what is this stream? See, okay, just instead of this we can have another symbol that is more good to see or understand. That will be like, so we are having this symbol. So we assume that this is our stream, right? This is our stream. Now what do you mean by stream? See, if you can imagine flow of water in a stream. Can you relate it? Flow of water in a stream. That means one by one. Isn't it? Can you understand the meaning of stream in English language? Flow of water in a stream, right? Similarly, if I say the compiler creates a stream, now by that I mean the compiler will create a flow or any technique, or indirectly I can say it's a pipe through which the data will flow from program to this file. Did you understood this? The data will flow from program, that means this data to be written from program will be saved in the form of file. So this stream, which is used to write the data from program into the file, is called as off stream, or we normally call it as output stream. It is called as output stream. Now why we call it as output stream? Because we are the output of the program, or the value from the program is written into the file. So that is called as output of stream. Now similarly, if this is output stream is also used for writing data into file from the program. Okay. So this is output stream. Now similarly, if I want to read the data from the file, in that case, I will be having which stream? I'll be having an anybody who can answer this question? To take an input from the user, I'll be having input stream. And the direction of the stream will be from file to program. Whatever it is written into the file, whatever is written into the file will be read by the program. So it is an input to the program. So it is an input stream. Okay. And we always also call it as reading from the file, or I can also call it as taking input from the file. Okay. So this output means from program, writing something from program into file, and reading means, or input means reading data from file by the program. So is it clear to all? What is input stream and output stream? Why do we use it? Is it clear to all? Yes? I'll tell you, Suresh, off stream means. Off stream and if stream, I'll tell you. Till now, please get clear with output and input stream. Okay? So I hope this is clear to all by everybody. Now, next is, let me just clear it all. Now, next is we have multiple types of streams in C++, right? We have multiple types of streams in C++. So the very first one is, let me just draw the same in front of you. It will be more clear to you. So the very first one is we can have this as a diagram. Okay. Now, the very first one, or I can say, now one thing I want to tell you in the previous diagram. See, this off stream in C++ is represented via creating the object. I repeat, we need to create an object to perform the off stream or the output stream or the input stream function. So with the help of object, we perform the reading and writing. So if I create an object of a class, that represents the stream. Okay, object represents the stream in C++. I'll tell you what it is with the help of program. So let's come back. So the very first one is ISO. ISO, right? Now what is ISO? Or I can, it's not ISO, it's iOS. It is IO. IOS. Now I stands for input, O stands for output, and S stands for stream. So the what is iOS? iOS is actually a class. This is the primary class which is available in C++ to perform the input and output functions in the file via program. So the very first topmost class available to us is called as iOS. Now, inside iOS, we have the file, another class called as Iostream. We call it as Iostream. And similarly, we have another class called as Ostream. Okay, Iostream and Ostream. Now, these both classes are inside the header file called as this Iostream and Ostream. Okay, so both Iostream and Ostream are inside the class header class called as iOS, right? Now, what is iStream? iStream is used to taking input or creating the input stream, and OStream represents the creating the output stream. Now, in this inside this iStream class, we have further two classes. One is called as ifstream and the other is called as if stream with assign. If stream with assign. Now these both classes are inside the class called as header class called as Iostream, right? Similarly, in case of Ostream, we have two classes. One is called as OF stream, off stream, and the other is called as off stream with assign. Okay. Now, also we have some class, another class called as Iostream, right? And there's a class called as Fstream. I'll tell you what is all about it. I'll just complete it and let you know. Okay. Okay. So this is like our complete types of streams available to us. Now, what is iOS? As I've told you, iOS stands for input output stream. This is the header stream. Okay, head stream. Now in this stream, in this class, all the classes come inside it. So there are mainly two classes inside iOS class, that is iStream and OStream. iStream class is used to perform the input, create the input stream, and OStream class is used to create the output stream. Okay. Now iStream is further divided into two things. One is ifstream and ifstream with assignment. It's not if, it's iStream with assignment. And similarly, in case of OStream, we have two things. One is offstream and OStream with assignment. Now, let me tell you that what is ifstream and OStream. So talking about iStream, see, if I want to create an input, take an input from the user, or if I want to write something on the screen to performing the input operation, I'll be using iStream. Okay, it's just to perform the reading something from the user, or I can say taking input from the user or taking input from the file. Okay, or the program. Now. Okay, so if I want to take input from the user, which function do I use? I use cin. Yes or no? If I want to take input from user, I use the function cin. Actually, cin is not a function; it's an object. It's an object. Now, cin object is defined inside which class? It is defined in iStream with assignment. So why we call it as cin? Cin is used to take input from standard input device, which is your keyboard. Okay. And similarly, if I want to print or something on the monitor or give output on the screen, I use which function? Cout. And cout means get output or print output of the program on the screen. So in that case, this cout is an object lying inside which class? It lies inside OStream with assign. So it comes under this OStream with assign class. Is it clear to all? This much is clear to all? Yes or no, please? Okay, Aniket, I was saying that streams are actually the flow, or it is actually a technique by which we write something into the file or take input from the file. Now, basically, the header class is called as iOS input output stream. Okay, input output stream is having two streams inside it. One is called as iStream and the other is called as OStream. iStream is used to for writing or giving input or taking input from the user to the program. Remember, it is to the program. Okay. We need to take input to the program. Okay, so iStream is further having two classes. One is called as iStream with assignment and the other is called as ifstream. Now we know that there is an object inside C++ known as cin. Cin is an object used to take input from the user. We normally write like this, cin a, and whatever user give as an input to from the keyboard, it is saved in a. So cin object is defined under which class? It is defined under iStream with assign. Okay, and if I want to read something from the file, I will use which class? I will use ifstream. I stands for input, F stands for file, and stream stands for stream. So input file stream. This is used for taking input from file, and this is used for taking input from keyboard. Okay. Similarly, if I talk about OStream, OStream has two classes. One is offstream and offstream with assignment. In C++, we normally use an object called as cout. This is used to print something on the screen. So if I say cout A, the value of A is printed on the screen, right? Now this cout lies under which class? It lies under OStream with assign. Okay. So I can say to what is OStream used for? OStream is used to take output from program to file or to screen. Now, if I want to take output from program and print it on the screen, so for that I'll use which class? OStream with assignment. But if I want to take output from program and save it in the file, in that case I'll be using offstream. So this is writing into file. In the other words, you can say this is reading from file, and this is writing into file. Is it clear? Is it clear to all? Now there is another class which is the combination of both iStream and OStream, which is called as Iostream. There's another class called as Iostream, which is the combination of both I and OStream. That means input output stream. And the class which belongs to Iostream is called as fstream. So whenever I'm using fstream header file in my program, that means I can perform both read and write operation onto or from the file. So is it clear to all? Okay. So normally which file do we use in our program? We use fstream, because we can perform with the help of this header file, we can perform both read and write. So this is the header file which we are going to use in our program. So any doubt to anybody in this? Types of streams? Any doubt to anybody? Okay, now let's come to the practical aspect. I'm just clearing this all and try to do some programming on these streams. So I've created one project. So it's my project called mainstream cpp.main. Now in this I'm going to use, since I have to perform the operations on file, I'll be using which header file? I'll be using Iostream. Okay, why Iostream? Because Iostream includes both input and output operation on the file. So this is done. Then I say I'll be using hash include conio.h. Right, I say using namespace std. If you use namespace std, you don't have to mention h as an header file. Okay, so next let's begin our program. So void main. Now I say I have to, the very first operation I want to perform is I want to write a message on the into the file. So my program is write hello into .txt file. Okay. Okay, so this is my program. So I'm having void main. Now I need to perform write operation. So which stream will I use? I will be using off stream. O stands for output, to write the output of the program into the file. Right. Now this is the header file which I'm using, off stream. It's a class. Off stream is a class. Header file. This class is defined inside which header file? Iostream. So offstream is the class. Now I'm going to create an object of this class. So I am using fout. So you can have create any object name. That means you can write any object name here. I'm writing here fout. You can write ABC. It's up to you. Okay, but the class name should be offstream. Okay. Then I say this object represents what? Fout represents this stream. This stream. Okay, output stream. So then I say fout dot open. Now with the help of file, this with the help of object, what I have to do, I have to open the file first of all, because without opening I cannot write anything onto the file. So I say fout, I'm creating one file abc.txt. Okay, right. Then I say fout. See, normally to write something on the screen we use cout. Yes or no? We write cout. Hello? Yes, please. We normally write cout. Yes or no? To write something on the screen we use cout. But here I do not want to write on the screen. I want to write this hello string into the file. So what I am going to use, instead of cout, I am going to use fout. Fout means object name. Okay, so fout hello. Okay, and then I say get ch. Now anybody who can tell me, have I created the abc.txt file by myself? No, yet I have not created any abc.txt file. So what is the use of this open function? This open function is going to create this abc.txt file if it is not created. Okay, what it will do, it will first of all create this abc.txt file and then open that file in the write mode. Write mode means output mode. Is it clear to all? Now if it is already there, abc.txt file is already there, in that case it will not create it. But if it's not yet created, it will first of all create it and then open it in the write mode. Any doubt to anybody in this? Okay. Now where this file will be saved? This file will be saved in the bin folder, or it will be saved in the current working directory where my C++ is program is executed. I repeat, this file will be created in the current working directory where my C++ program is executed. Now let's suppose if I want to create this file on my desktop, on my desktop, in that case what I have to do, I have to mention here the path. Is it clear to all? Is it clear to all? If I'm not mentioning the path, by default file will be created in the current working directory. But since I have not mentioned the if I want that the file should be created in the desktop or any other folder, in that case I have to mention the path of that folder. So is it clear to all? Now here I'm not mentioning any path, so by default it will be in the current working directory. So let me just execute. So before executing, let's see here. Let me open this where my file will be created. So I am having my C drive, right? In C drive, I am having program files. So I need to find out the folder where my code blocks is created. I need to find out the code blocks folder. So probably in program files, yeah. So here is my folder called code blocks. Inside that, there is a folder. Do I have it? Let me check it out where it is created. Yeah. So here I'm having inside code blocks, inside program files, I'm having a folder called code blocks. Here I'm having min GW folder. I'm opening it, and then I'm having bin. Now in bin, my file will be created. So do I have any ABC file here right now? abc.txt file here right now? Search bin. I'm having an ABC file .txt. No, it says no, right? Now, once I execute the program, what will happen? ABC file will be created. Okay. Now, let's do one thing. Okay. Let's execute this program. Okay. It's always return me. See, yet the program is executing. Program is executing, it's taking time. So just hold on for a minute. Okay. So this is my output screen. Nothing is coming here, right? So I just press, I say it's press any key to continue. I press it, okay, and it ends. So my program is compiled successfully. It is executed successfully. Now let's see whether the file is created or not. So again, I go back to my folder. The application server which actually that's something which is owned by Desktop. I need to find out that whether the abc.txt file is created here or not. Check it out. He said we can have a discussion with Naveen and Jennifer because they are going to be going forward also. So let me check it out, my projects folder. We definitely have to have a discussion with Jennifer. So inside here project folder, I have created one project called as Iostream, right? I'm having a bin. So you can see here an abc.txt file is created. Yes or no? So here this abc.txt file is created. I'll just open this file with Notepad. It's not written anything. To find out why it's not. Okay, this ABC file is here, which I was talking about. abc.txt, right? I'll open it with the notepad and you can see hello is written here. Anybody having doubt here? So by default, my file is created where? It is created in the projects folder where I have my program with projects being created. So let's do the same again. Let's just delete this file. Okay. Now I'm come back to my program. Okay. Now let's see whether this file is created or not. I'll be showing you how it is being created, how the data is being written into it. So my data is hello. Okay. I just modify the same program. I write here file get.ch. Now with this editing, whatever I write here, you'll come to know that file is written or not. So one thing I need to tell you, see, whenever I'm writing something into the file, or I can say whenever I'm using Iostream as my class, whenever I open the file to perform, to ensure that whatever I write into the file is permanently written into the file, what I have to do, after writing, I have to close the file also. So if you do not close it, the write operation is not performed into the file permanently or into the storage area. Okay, so this is we need to ensure. If you open it, we need to close it also in case of writing operation. In case of reading, it's optional, you want to close it or not. Okay, so I just saved the program. Now please, I'll be opening that folder in front of you so that it will be clear. Okay, so this is my program. So that you can see the operation being performed immediately on your screens. Okay, so this is your folder where the files will be created, and this is the program which I'm running. So I run this, save this program, build and run. So my program is running. See, as you can see, as I run this program, this ABC file is created. Okay. Now, what is the size of the file? It is 0 KB. Till now, it's 0 KB. That means the file is created, fout.open is executed. Now, the second thing which is executed is get.ch. Now, what is the role of get.ch? See, here I'm getting a blank pointer. That means my compiler or the program is waiting for me to press any key. So here comes the role of get.ch. Get.ch is that my compiler is waiting for me to press any key, and after pressing the key, what will happen? The next line will be executed. That is fout hello. Okay. So till now only the file is created, that is abc.txt, and the line which is currently executing is getch. So I press here some key, right? Now the fout hello operation has been performed. Okay, so write operation has been performed. Where is my write operation has been performed on my, just come back to it, right? Just a second, I'll be opening up the same for you. The code blocks too, right? So till now, how many getch have been executed till now? Anybody who can tell me? Till now, 2 getch have been executed. The very first one was creating after opening the file, and getch was executed. I pressed the enter key, any key. Then the output operation was performed, hello, and again it's asking me to getch. So I press any key. Okay. Now you can see as soon as I press key, the size of the file changes from 0 KB to 1 KB. See, till here, till this statement, fout hello, the size of the file was 0 KB. Data was not written into it. So it was asking me to perform the getch function. It was asking me to press enter. As soon as I press enter, the data was updated into the file and the size changed to 1 KB. Okay. And so size changed to 1 KB. And then I say fout.close. So currently, which getch is working? The third getch is working, and it is asking me to press enter again. So I press enter. So third getch is completed. Now this is the end of the program. So again, it asks me to press any key to continue. I say yes. Okay. So this, is it understood by all? Is it understood by all that what is working, how it is working? Till here, file is opened, getch, I write something into the file, getch, the size of the file will be 0 KB. But as soon as it runs fout close, the file size of the file changes to updated size. Now you can see the size of the file is 1 KB. Size of the file is 1 KB. How many characters are there? How many characters are there? Yes, please. 5. So what should be the size of the file in this case? See, size of the file depends upon the number of characters you are storing. Okay, number of characters you are storing. And one thing I need to tell you, it's a string, and string always ends with null character. If you remember in case of C, I told you string always has a null character, and that null character does not carry the memory in the file. I repeat, null character does not carry the memory in the file. So I hope it's clear to you how to write something into the file. Now let's perform the second operation. Second is reading operation. Reading from the file. Okay, this was writing. Second is reading. Okay, so I say read, modify the same program, read from abc.txt, right? So I am having the header file same, Fstream, Iostream, corner.h, using namespace std same. I say int main. Now, first of all, I say clear screen just to remove the previous output. Okay. Now, since I have to perform the reading operation, now for reading operation, the class used is Iostream. Okay. Iostream. And again, for Iostream, I'll be creating one object. I can call it as fin file in. You can write any object name here. So I say now to perform the reading operation, first of all, I have to open the file. So I write fin.open abc.txt. Okay. Now I'll just remove this. Right. Now I say fin. See, let me tell you that one thing that, okay, before just writing it, I'll take a variable ch, cache ch. Now this reading from a file, see, what is the data? Data is hello, right? Data is hello in the file abc.txt. Now I am taking a variable ch. Okay. Now if I want to read this data hello from the file, I have to first of all store it into a variable ch and then print the ch variable. I repeat, whatever the data is there in the file, I will store it in the variable ch and then print the ch variable. Okay. Now reading the data from the file will be done character by character. I repeat, reading the data from the file will be done character by character. So what will happen? First of all, h will be saved in ch, then e will be saved in ch, then l, and then again l, and then o. So this complete string is not read in one go. Rather, the reading operation is performed character by character. Is it clear to all? Is it clear to all? Okay. So I say fin. If as I write cin, I will be writing here fin. So fin ch. Now this is clear. Okay. I say fin dot close. I say get ch. Just let me run this. Int main. Is it clear? Screen was not clear. Just let me remove this. It's yes. Why I'm not getting the output here? Anybody who can tell me? Anybody who can tell me why I'm not getting the output here? See, I have taken the data from the file and save it in ch. But have I printed the ch variable here? Have I printed the ch variable here? So how will I get the output on the screen? So what I have to do? I have to write cout ch. Okay. Oh. What is the output I'm getting? I'm getting here h. But what is the string here? String is hello. String is hello. But I am getting here h. That means since I've written here fin ch, this command is going to put h inside ch and print the, bring h into the ch variable and print the ch variable. That means only one character is read by the system. By the system till now, yes or no? Reading is performed character by character, yes or no? Right? Now, if I want that the complete string should be read by the system into the ch and then print ch. So in that case, what I will do, I will be using a loop. And loop says while fin dot end of file. What is an EOF? EOF stands for end of file. Now, until my system, fin.eof means I have to go to end of file. Now, if I go to end of file, my loop will execute or not? No, it will not be executed. So I say until and unless I do not reach end of file, not fin dot end of file. Until and unless I do not accommodate, I do not find the end of file character. See, after your data HELLO, there is a pointer which is called as end of file pointer. So what will happen here? My variable, my compiler is going to read H here, right? And move to next pointer. Next pointer says E. It will read it and move to next pointer. Next is L. It will read it and move to next pointer L. It will read L again, moves to next pointer O. It will read O, okay, and then moves to next pointer. So what is the next pointer? End of file. So if this end of file, if I say if while end of file, while not end of file, so if it becomes end of file, this while will terminate, this condition will become false, and we will come out of the while loop. Okay, I think we have already done while loop, so it's not to be told again. So while end of file, what you do, in, cout, ch, right, and then fin ch. Is this clear to all? Is this statement clear to all? Is this loop clear to all? Do I have to explain this loop? Okay. So save it, build and run. So you can see hello here. Okay. So this statement reads H, cout H, then again go to next pointer, reads E, cout E, then go to L. Okay. I'll tell you. See, the string is hello. String is hello. Okay. I say my starting position is H. Yes, my starting position is H. I am taking a variable ch. Okay. I say fin ch. So what will happen at this position? Fin ch, what will happen? H will go into ch. H will go into ch, right? Then I say while current position is not end of file. Is my current position end of file? Yes or no? No. So what will happen? It's this condition is true. It is true. So what will I go? I'll go inside the loop. I'll say cout ch. So this currently ch is having what? H. Currently ch is having H. So it will print it on the screen. H will come here. Let's suppose this is your screen monitor. Okay, right? Then I say fin ch. Now next character is read here. Next character is read here. So current pointer is E, right? So next character here comes E, right? Aniket, I'm assuming that abc.txt file is already existing in the previous program which we have created. So that file is already there now, and it is already having a string hello. So I just want to print the contents of that file. Yes, that contain the hello. So I just want to print the content of the file. That is why I'm putting the same name, abc.txt. Okay. So then comes E. E will be printed here, right? Again the loop goes back. It says fin ch. So next pointer is L. L will go here. It will print L. Again, pointer increments, L will go here. It will print L. Again, in pointer increments, O will go here in CH and O will be printed. Okay, so fin CH means from file, put the value into CH variable, and cout CH means from CH, print the character on the screen. So is it clear now, Aniket? Yes, Aniket, is it clear now? Okay. So this was the first program which we did was to write something on the into the file, and this program is to read from the file. I hope both the programs are clear to all. Okay. Now next thing is, let's suppose I have a file. I'll just modify the file. I need to tell you some concept. So the file was this file, ABC. I'll open this file. It is having hello. Now I'll write the contents, hello students. I'm updating the file. I'm writing here hello students. I save it. I close it. Okay. I run the program. The program is to read from abc.txt. Okay. I'll run the same program again. So what should be the output on the screen? Yes, everybody. Anybody who can tell me what should be the output on the screen? Yes, can I get the answers? Hello, not hello. I've just updated this file. Niket, I've updated the file. It says hello students. Yes or no? Yes. So the content should be hello and space students. Okay. So this is the expected output. Now I run this program again. So what is the output I'm getting? Hello students. Is there any space here? No space. But in my output file, in my abc.txt file, there is a space. Yes or no? In my ABC file, there is a space. But when I print that contents on the screen, I'll show you. See this abc.txt. Yes, see here. Hello students. There is a file. There is a space, right? There is a space. This ABC. Can you see Aniket here? ABC notepad. There is space. Hello students. Yes, Aniket. But on the output too, I'm having students. No. So where is the space now? So where does the space goes? That means whenever I read from the file, while reading, my compiler ignores the space. I repeat, while performing the read operation of this, we know that space is a character. Yes or no? We always consider space as a character. But while performing the read operation, my compiler is going to ignore the spaces. My compiler is going to ignore the tabs, and my compiler is also going to ignore the next line. See, let's suppose I write something on the next line. I write here, hello students, how are you? Okay. So I save this file. Now you can see hello space students, and then the next line I'm having hello, how are you? I save this file, save, I cross it, I rerun the program. See what I'm getting. Hello students, how are you? Without spaces, without next line. That means my compiler, while performing the read operation, ignores the spaces, ignores the next line character also. So how can I get the exact output on the screen? Now to get the exact output on the screen, instead of writing this statement, fin input ch, what will I write? I'll write here ch is equals to fin dot get. There I'll write here ch is equals to fin dot get. That means I'll be using get function. Okay, to get the exact output on the screen into the ch file. Here also I'll not be writing this. I'll be writing here ch is equals to fin dot get. I'll save it because see Aniket, if I write this fin extraction operator ch, in this case, while extracting the characters one by one, it ignores spaces, tabs, and next line. But if I want spaces, tabs, and next line should be considered as a character while taking the input from the file, in that case, I can use get function. In this case, it is ignoring. Okay. In this syntax, fin extraction operator ch, it is ignoring. It is not taking this spaces. Okay. Because Aniket, there is a syntax for it. It's a syntax. It's a proper inbuilt function. Okay. But if I want, it should take as a character, I'll be using get function. Okay. So I save it, this program, I'll run it. You can get the exact output. Hello, space students. In the next line, how are you? So is it clear to all? Yes, is it clear to all? Can I get your answers, please? So with the help of get function, I can get the exact output on the screen. Okay, with spaces and with the next line character. Okay. This was get function. Now next thing which I want to tell you is that modes, file opening modes. File opening. Now what are the file opening modes? See, we have iOS. It is used to perform input, or we also call it as operation. Okay. I'm having one mode called as iOS out. It is used to perform output or write operation. I'm having a mode called as iOS app. It is used to append the data into the file. I'm having a mode called iOS ATE. ATE, it is used to perform the update operation onto the existing file. And I'm having one mode called as iOS binary. It is a binary operation. I'll tell you what is this. Okay, so there are actually four modes. There are four modes in which we can open the file. One is called as iOS, it's small I. iOS scope resolution operator and in. It is used to perform the input operation or read operation on the file. Next is iOS out. It is used to perform the output operation or write operation on the file. Now let me tell you that whenever I open the file in out mode, what will happen? The existing file, if there is already a file called as abc.txt. Okay, let's suppose I have a file abc.txt which contains the data hello students. Okay, it contains the data hello students. If I open this file abc.txt in which mode? iOS out. What will happen? This contents will be deleted. I repeat, this contents will be deleted and an empty file will be recreated. Okay, iOS out is going to delete the previous content and an empty file will be recreated with same name. Okay, But if I open the file in append mode, what will happen? The same file abc.txt will be created with the current position of the pointer at here, at the end of the file. So whatever new data we write at this position after the existing data. Append means to add the content to the existing file. Okay. Next is iOS 8. iOS 8 is used to update the existing file. Okay, that means to change the data into existing the characters or existing string, I can use the update option. Okay, now let's do this practical one. Okay, so let's do the practical one. I say, let's just remove it. I need to write something on the screen. Okay, in that case, I'll be using Offstream. To write, I'll be using Offstream, and I use fout. Okay, then I say fout dot open. The name of the existing file is abc.txt. So I'll be writing here abc.txt, right? In inverted quotes. This is the first argument, right? And the second argument is, see, I do not have to write iOS in and iOS out because they are the default argument. Even if I do not write on the screen, what will happen? A new abc.txt file will be created. But if I want to make changes in the previous file, in that case, what will I use? iOS app. So how will I use it? I say iOS export resolution operator app. Okay. Right. And what is the current data? What is the current data in my file? What is the current data in my file? Let's open it up and see. The current data is hello students, how are you? Right. Now I want to add more data into this file. So for that, I'll be writing here f4 out. This is C++ session. Okay. I end it and I say get th. I save it. I run it. See, the current data is hello students, how are you? Okay. I'll just close it once so that the final write operation can be performed. I save it, wait and run. Okay. So nothing should be printed on the screen because I'm not printing anything. Okay. Let me open my file and see the data. Hello students, how are you? This is a C++ session. So did you understood this? Did you understood this concept? Yes, everybody please respond. If I want to make changes in the existing file, I'll open that file in which mode? I'll open that file in the append mode. Okay, so is it clear to all? Yes, please respond. Okay. Now the last mode which I need to tell you is binary. Okay. Now what is binary? See, let me tell you. I'll just close this file. Let's suppose the data I write into the file. Okay, just this is session. Okay, I open the file in append mode. I write backslash n, and I say this is C++, or I write here today is Monday. Today is Monday. Now, if I open the file in front of you, where is my current position? Current position is current pointer position. Yes, everybody, please tell me, where is my current pointer position? My current pointer position is this. After session, this is the end of the file pointer. Whatever I write will be written here. Please do not do all this. My current position is this. So whatever I write here will be added on to this at this place, right? Now, if I want that whatever I write should be taken to the next line and printed here. In that case, what I'll use backslash n. Okay, I'll use this backslash n. This is for next line. This is for next line. Okay, so let me run this program. If I write a backslash n, this is a special character to tell the compiler that you have to move to new line, next line, or new line. Okay, so the effect of backslash n can be seen by this u. Okay, so I save it, I build and run. So nothing will be printed. I say exit. I'll just close it and open it again because it's the previous. See, today is Monday. It's on the new line. Is it clear to all? Yes or no? Yes. Okay. But what I was talking about is the concept of binary. Okay. Now see everybody. If I open the file in append mode, also I say the file should be open in binary mode. Open in binary mode. We can open the file in multiple modes also. One thing you should be clear of. I'm saying the file should be open in append mode and also it should be open in binary mode. Okay. Now in that case, the special characters has no role to play. See, even if I use here backslash n, for a compiler, backslash n means new line. But if I open the file in binary mode, this backslash n or backslash t or any special character has no meaning. So whatever you write here, backslash n, backslash t, will be as it is taken as a character and printed on the screen. You understood this concept? When I open the file in binary mode, the special characters has no role to play. It will be taken as a simple character and this backslash n will be printed along with this line on the screen. So what will be my current pointer here, position here? Anybody who can tell me? Current position is this? Yes or no? Current position is this? Yes or no, please? Yes, so this is my current position. And whatever I write now will be written here. Okay. So, but I'm saying there is a character, there is a special character, backslash n. Okay. But the type of the file is binary. So let's save it and run it. See what happens. Argumentally provided. It only works. It only works. Just let me check it out. What we need to do in that case. I can have 2, 3. 2 or 3. What do you think? Can we have 2 or 3? If I open it in this mode, it should work, but why it is giving error? I need to check it out. It says expected 2 arguments and then it gives you 3. If I write here, iOS binary. Okay, part of iOS, so it should work. Because it tried it. Stream. Two arguments expected. It is going to, if I remove append, it is going to open the file in output mode. So I don't have to remove append in that case. Let's see if I can do here. Okay. Let's see if I remove here comma iOS app and space here and then iOS binary. Written run. Okay. It says expected for iOS. Let's remove your space then. Must be having some solution, and that could be Can we have a pipe operator over here? Let's try it. Yeah. So no output, nothing. See, if we use pipe operator, we can add two of this modes, and it should not be separated by comma, semi-commas. So the data which we wrote is today is Monday, right? So I am expecting that /n will be coming as it is in the output file. So I run it. You can see here. It is not coming as it is, but what it is giving you is also, it is not giving any effect. It's not giving any effect on this as a part or special character in the compiler. It is not taking your output to the next line. Is it clear? Is it clear to all? Yes or no, please? I will not try this two operators together. That is why I was also having any doubt here. Since here, what is this operator called as? It is called as pipe operator, and you can find this operator above the enter key on your keyboard. Okay, above the enter key on your keyboard, there is a pipe operator, and you can just use this pipe operator to add two modes of operands in your while opening the file. So with this, we are having the basic syntax of opening and writing data from the file, reading the data from the file, and the modes, right? So tomorrow we will be performing the seeking operation, and with that, I end up my today's session. Tomorrow we'll be continuing with the files and streams, and we're doing one more topic that is called as exception handling. So if you have any doubt on this, you can let me know. Okay. So with this, I end up my today's session. Thank you. Have a good day.